Welcome, fellow explorers, to the fascinating world of logic. Our journey begins with the fundamental building blocks of reasoning propositions. In the vast universe of thought, propositions are like stars, each shining with the light of truth or falsehood. A proposition is a statement that can be either true or false. It's a declaration about the world around us, a claim that can be evaluated. For instance, the Earth is round is a true proposition, a fact confirmed by countless observations and scientific evidence. On the other hand, the moon is made of cheese is a false proposition. While imaginative, it doesn't hold up against our understanding of celestial bodies. Remember, a proposition must have a truth value even if we don't know it yet. There are life forms on other planets is a proposition, though its truth remains a mystery waiting to be unraveled. Keep in mind that the truth or falsehood of a proposition is independent of our beliefs or opinions. Even if everyone on Earth believed the Earth was flat, it wouldn't change the fact that it's round. Truth, in the realm of logic, is objective and unwavering. As we navigate the cosmos of logic, it's crucial to distinguish planets from stars, propositions from other types of sentences. While propositions are the cornerstones of logical reasoning, not every sentence we utter qualifies as one. Questions, for instance, are not propositions. They seek information rather than stating it. Is the sky blue? Doesn't declare the sky's color but inquires about it. Similarly, commands like close the door are instructions, not claims about the world, and therefore not propositions. Exclamations too fall outside the realm of propositions. Wow expresses surprise or awe but doesn't assert a truth value. These expressions, while essential to human communication, don't fit the mold of propositions. Distinguishing propositions from other sentence types is vital for clear thinking. Just as astronomers differentiate planets from stars, we must carefully categorize the statements we encounter to apply logical principles accurately. In our exploration of logic, we often encounter a multitude of propositions. To keep track of them and manipulate them efficiently, mathematicians have developed a shorthand notation, a symbolic language that simplifies complex logical expressions. We use lowercase letters like P, Q, and R to represent different propositions. For example, we can let P stand for the proposition, the Earth is round, and Q for the moon is made of cheese. This notation allows us to express logical relationships concisely and clearly. To indicate the truth value of a proposition, we use the letters T for true and F for false. Thus, we can write P equals T to express that the proposition the Earth is round is true, and Q equals F to indicate that the moon is made of cheese is false. This symbolic language is like a universal translator, enabling us to communicate logical ideas precisely and unambiguously. By assigning symbols to propositions and their truth values, we can build complex logical expressions and analyze their truth conditions systematically. As we delve deeper into the universe of propositions, we encounter an intriguing phenomenon. The truth value of some propositions can change depending on the context. These shape-shifting statements, known as context-dependent propositions, add a layer of complexity to our logical landscape. Consider the proposition it is raining. Its truth value depends on the location and time of utterance. It might be true in London on a Tuesday afternoon but false in sunny Los Angeles at the same moment. Similarly, the proposition she is tall depends on who she refers to and the average height of the group being considered. Context-dependent propositions remind us that truth, while objective, can be relative to specific circumstances. Just as the appearance of the moon changes depending on its position in the sky, the truth value of some propositions can shift depending on the context in which they are uttered. Section 5. Flipping the script, the power of negation. Our exploration of logical operations begins with negation, a fundamental tool that allows us to express the opposite of a proposition. Negation is like flipping a switch, changing the truth value of a proposition from true to false or vice versa. We denote the negation of a proposition using the symbol. If P represents the proposition the sky is blue, then P represents the sky is not blue. When P is true, P is false, and when P is false, P is true. Negation is a powerful tool for expressing disagreement, contradiction, and alternative possibilities. It allows us to explore the logical space around a proposition, considering both its affirmation and its denial. Understanding negation is crucial for analyzing arguments, identifying fallacies, and constructing sound logical proofs. It's the foundation upon which more complex logical operations are built. Section 6. Two truths make a truth, the realm of conjunction. As our journey through the world of logic continues, we encounter conjunction, an operation that combines two propositions into a single statement, asserting that both are true. Conjunction is like a logical and linking two truths together. We denote conjunction using the symbol. If P represents the Earth is round and Q represents the moon orbits the Earth, then PQ represents the proposition the Earth is round, and the moon orbits the Earth. The truth of a conjunction depends on the truth of its components. A conjunction is true only if both propositions are true. If either proposition is false, the entire conjunction is false. Conjunction allows us to express complex ideas by combining simpler ones, building a chain of truths that strengthen our logical arguments. It's a fundamental tool for expressing conditions, dependencies, and relationships between different propositions. Section 7. 1. Truth is enough. Stepping into disjunction. In the expansive landscape of logical operations, disjunction plays a crucial role, allowing us to express the idea that at least one of two propositions is true. Disjunction is like a logical or offering a choice between two possibilities. We symbolize disjunction using the symbol. If P represents it is raining and Q represents the sun is shining, then PQ represents the proposition it is raining or the sun is shining. Unlike conjunction, disjunction is more forgiving in its truth conditions. A disjunction is true if at least one of the propositions is true. It's only false if both propositions are false. Disjunction provides flexibility in logical reasoning, allowing us to consider alternative scenarios and account for situations where multiple possibilities might hold true. It's a valuable tool for expressing choices, possibilities, and inclusive conditions. Section 8. Truth tables, mapping the landscape of logic. As we venture further into the world of logic, it's helpful to have a visual tool to track the truth values of complex propositions involving negation, conjunction, and disjunction. This is where truth tables come in, providing a systematic way to analyze logical expressions. A truth table lists all possible combinations of truth values for the propositions involved, and shows the resulting truth value for the entire expression. For instance, the truth table for negation has two rows, one for P being true, and one for P being false. It shows that P is false when P is true, and vice versa. Truth tables for conjunction and disjunction have 4 rows each, representing all combinations of truth values for P and Q. These tables illustrate the truth conditions for these operations, showing how the truth value of the compound proposition depends on the truth values of its components. Section 9. The exclusive or one truth, no more, no less. Our exploration of logical operations wouldn't be complete without introducing the exclusive OR, often abbreviated as XOR. XOR is a special type of disjunction that requires exactly one of the two propositions to be true, not both. We denote XOR using the symbol. If P represents the cat is black and Q represents the cat is white, then PQ represents the proposition the cat is either black or white but not both. Unlike regular disjunction, which allows for the possibility of both propositions being true, XOR excludes this case. It asserts that one and only one of the propositions must hold true. XOR is a powerful tool for expressing mutually exclusive choices, situations where only one option can be true at a time. It's a valuable tool for representing binary states, decisions, and scenarios where exclusivity is paramount. Section 10. Logic and action. From theorems to everyday thinking. Congratulations, fellow explorers. You've now journeyed through the fundamental concepts of propositions and logical operations. But the true power of logic lies not just in understanding these principles, but in applying them to real-world problems and everyday thinking. From proving mathematical theorems, to evaluating arguments, making decisions, and even understanding the nuances of language, logic provides a framework for clear critical thinking. It helps us identify fallacies, construct sound arguments, and navigate the complexities of information overload. The principles we've explored today are not just abstract concepts confined to textbooks. They are tools for understanding the world around us, for making sense of the information we encounter, and for making informed decisions. So, embrace the power of logic, and let it guide you on your journey of intellectual discovery.